Hello, everybody. My name is Jim Pingle, and welcome to our February 2016 pfSense Hangout. This month we'll be talking about traffic shaping basics using the PRIQ scheduler. Just a quick brief overview of what we're going to go over this month. We've got project news as always. We'll talk about what traffic shaping is, how traffic shaping works. We'll look at several different types of traffic shaping available in pfSense, limitations of traffic shaping, why we're going to use PRIQ. Go through the traffic shaping wizard, look at the queue structure, talk about matching and queuing the traffic with floating rules. We'll do some testing and troubleshooting, and we'll have some Q&A at the end. I just want to let you know we are just going to stick strictly to the PRIQ scheduler this time. I'll briefly talk about HFSC and a couple other things, but we're not gonna demonstrate anything with that or go into any questions or anything about HFSC or any of the other queues. We're just going to do PRIQ this time. We'll have another hangout in the future for another scheduler type, but for now we're just trying to keep things pretty simple with PRIQ. Okay, project news for the month. We might have a 2.2.7 release. We are not 100% certain yet. We've had a couple of minor security fixes that we've put in, and there's apparently an OpenSSL version that's coming out, but they haven't given us any detail about what it is. They said it's a high severity, but we don't know if it's a function that pfSense employs, or that we may have to worry about, or if it's an area that we don't touch and don't use that may not be relevant to us. So we're kind of on the fence about that, but we'll see what happens next week. Keep an eye on the blog. We'll have that straightened out. Our 2.3 release is nearing release candidate stage. It's getting close. We're trying to keep in track with the FreeBSD 10.3 release schedule, which is almost there as well. They're looking for to have some movement there around the early parts of March. We're at a point now we're not doing any more new features. We're focused completely on bug fixes, and there's less than 25 new open bugs now. There's some in feedback state, a little bit more than that we need to get tested and closed out as well. But if you're not testing 2.3 yet in some capacity, you really should be. Now's the time to do it. Don't wait until after the release. Fire it up in a test lab or in a lesser used capacity, or even just in some way, any way you can test it with your own configurations. Let us know if something doesn't work right, because we do a lot of testing ourselves, but we rely on the community a lot for feedback as well, because there's certain combinations of functions and things that we may not run that other people do. So if at all possible, go ahead and get working with the snapshot and see what you can do. Let's see, we do have some new hardware coming up too. We have an XG2758 unit that's going to be replacing our C2758 unit. A little bit different build out. It still has 8 cores, 16 gig of RAM, but this one has 2 10 gig Intel ports with SFP jacks and 4 RJ45 1 gig ports that are also Intel. One of those is shared with RJ45 SFP, so you have a choice. You could have a 1 gig SFP or a 1 gig RJ45 on one of those 4 ports. So it's pretty slick. So I'm not sure the exact date, but we've got some more info on the blog if you're interested about that. Our European pfSense training tour we've got coming up. Our guys are going to be in the UK and Germany doing some training, April 7th to 8th in Bournemouth in the UK, thanks to our Amica partner. April 12th, 13th in London, in the UK, obviously, also with our Amica partner. And May 17th to 18th in Frankfurt in Germany. We got our Voltec partner taking care of us there. The training is going to be done by the same people who do it when it's online, but it will just be in person. If you're in Europe and you want to take advantage of one of those, you can follow the link there, netgate.com/training. All the training is going to be 9 a.m. to 6 p.m. local time. And then we're also going to have, before that, we'll have one more online training session, March 22nd to 23rd. So go ahead and sign up for that now if you can't make one of the in-person ones and you still need training. And as always, keep an eye on the blog and any new developments we'll have there, and also on Twitter and Reddit. Our guys like to post things there as well. Okay, well, let's get a little bit deep down into it. We'll just talk about what traffic shaping is, first of all, if you don't know, or if you're only vaguely familiar. Traffic shaping is a means to assure quality of service. So quality of service is a whole philosophy of providing delivery of packets in a timely manner. Traffic shaping is one way you can accomplish that, and a lot of people use the terms interchangeably, but they're not really the same thing. Traffic shaping accomplishes QoS by doing queuing and using criteria to control when it's delivered, whether it's by priority like PRIQ does, or whether it's bandwidth focused like other schedulers. It's different from traffic policing. So with traffic shaping, you get things that are queued. Traffic policing, when frames come in too fast, they are just dropped. It's a lot harsher. Shaping is a lot smoother technique. And shaping will pass important traffic like VoIP traffic, your TCP ACKs, gaming, things like that, at the expense of lesser traffic like SMTP. Those are just examples. Of course, you can classify things however you want, and we'll cover that later in the Hangout. Traffic shaping ensures that traffic is passed efficiently, meaning it tries to make sure that traffic still passes smoothly. You've probably noticed in cases like if you're downloading something heavy, or if you're uploading something heavy, your downloads really suffer with traffic shaping in line. And it will prioritize delivery of your acknowledgement packets out so you can upload and download utilizing your circuit in a more efficient capacity. Depending on your scheduler too, it can help with making sure that people share the load fairly as well. So you don't have too many people, one person can't hog the whole bandwidth, where it will try to help smooth that out as well. It can prevent traffic from overfilling circuits, so it kind of does a little bit of peak smoothing. If it sees things going too fast, it will queue things up a little bit to smooth that out, delay things a little bit, try and make it so it isn't going to get clipped off at the top. In some cases, it may have to drop some packets, but it will only drop packets once the queues are full, things like that happen. So yeah, as I mentioned, it shares bandwidth effectively across many clients. And also you could use it. This one is a little bit more of an ethical question for you and your own network, but you can discourage unwanted services by degrading the traffic flow. If you have traffic you can identify, or a person or service that you want to make, a known abuser or a known type of bad traffic you can identify, you could put its priority all the way to the bottom. That way its service gets degraded and it discourages its use, or otherwise penalize something. So how does this all work? With traffic shaping, you have a queue structure, and it specifies how the different types of traffic will be shaped or handled. Different structures have, different shaper schedulers have different structures with queues. In our priority queuing, we just have like a flat list of queues per interface. HFSC and others can have a whole hierarchy where there are trees and nested child queues under regular queues and so on and so forth, a few levels deep. So in these queues will define a priority or a bandwidth allocation, or like with the CBQ scheduler, it could be both. So they define places that traffic will temporarily be held while the shaping algorithm decides which packets get sent first. So the traffic gets into the queues when it's identified by firewall rules. So you match the rules, usually in floating rules. You'll match traffic, and then it will be placed into a queue, and then the scheduling algorithm will decide how to send that, according to the rules of the queues. Traffic and shaping is always done on in the outbound direction on an interface, because that's the only place you can actually limit your rates. Traffic inbound toward you has already arrived, and so you can't make it arrive any slower because it's being delivered to you by the other end. The other side of the connection, can fill you up. That's where, shaping like this is not really going to help you with like a denial of service attack, especially a bandwidth-oriented denial of service attack, because those are going to overfill your circuit on the way in, which you cannot control. It has to be choked off upstream. But you can control outbound, so that's where things get queued. Your uploads, for example, get queued outbound on your WAN as they leave. Downloads will get queued inbound, or as they flow through and leave your LAN interface outbound. Oh, sorry, somebody's asking if it's recorded. Yes, it will be recorded, and you can check the Hangout archive also on a member where you found the link for this. There'll be a link to the Hangout archive, and on there you can get in there and watch the old ones. Okay, so just a quick idea of how the processing works here with PRIQ. Your as I mentioned, your packets match rules. They're placed into queues. Packets are held momentarily before transmission in each queue, and then packets in the higher priority queues are always processed before lower priority queues. So if you have a constant stream of VoIP, that's always going to be sent immediately. Other traffic will get queued up behind that, and it will be sent as it can, assuming there's more room on the circuit for it. All right, different types of traffic shaping we have on pfSense. We have two main different types of traffic shaping. We have the alt queue scheduler, which you're maybe familiar with from the Wizard, and we have limiters. Under alt queue is what we're going to be covering today, and specifically we'll be covering the PRIQ scheduler for priority queuing. We get started there. Alt queue is done primarily in PF, and the priority queuing scheduler is one of the easiest and simplest to work with, so it's a good place to start with basics. The PRIQ scheduler is only concerned with priority. It has priorities for queues from 0 to 15, and the highest number of queues are processed first. So the Wizard only has a few different types of traffic that it classifies, so it only uses about 1 to 7. However, just for an example, since it uses 1 to 7, your VoIP queue, your highest is going to be 7, and then like peer-to-peer, your lowest is going to be 1. We'll cover the exact values of the queues later, but that's something to keep in mind. If you're going to be crafting your own things, you could use all the way up to 15 if you want. With PRIQ, like I mentioned, there's a flat list of queues per interface. There's no nesting, scheduling, or nesting children trees, whatever. It's just your interface, and under each interface you have a specific queue for each type of traffic. Another very popular type of shaping is HFSC, or hierarchical fair service curve. It's powerful, but it's really complicated and confusing. Its primary concern is bandwidth, as in throughput, and not priority. It decouples the bandwidth and the delay and everything. A lot more complication there. You can even do things like bandwidth guarantees and upper limits for traffic and link sharing and real-time requirements, and you can even do little bits of bursting, almost like bursting, but that's all in HFSC. But you can we certainly have documentation about that on the wiki and the book and on the forum, and there's a bunch of information out there, but it's a lot more complicated, which is why we're not going to be doing that one just yet. We're going to get started with PRIQ, and we'll build up to that in a future hangout. We also have the CBQ scheduler, which is class-based queuing. It's similar to HFSC, but in some cases it's not as accurate. It does have concerns for both bandwidth and priority, so it's even more flexible, but it doesn't have quite all the same algorithm concerns that HFSC does. So it's a little bit simpler in some respects, but for some people they might want to control things in a little bit in a manner that uses both bandwidth and priority. So they might go with CBQ. CBQ, it also does a lot better with borrowing and sharing of traffic among the queues, so it does things a little bit more fair. There's a couple of schedulers I'm not going to talk about right now called FairQ and CodelQ. Those are a little bit more special purpose, but you can certainly find documentation about those, like on the forum and the doc wiki and the book and whatnot. The other type, all those are alt queue. The other type we have is limiters. Limiters define buckets of bandwidth, and you can funnel traffic into those using rules. The buckets define an upper limit of traffic that can be shared. So you could have a limiter of, say, 1 meg for all web traffic, or all traffic from a given IP address. You can set up masking on a limiter to make that a per address or per subnet limit. And those are really nice for setting up, making sure people can't go over a certain limit. They have their limitations as well. At the moment on the 2.2x release, we do have issues with that, with pfSync and also some NAT scenarios. So be careful if you're trying to use limiters. But again, that's not going to be our focus today, but I wanted to put that out there and make sure you know they're there. I'm not sure why you might not be seeing the slide changes. I've got a second screen up here watching everything, and it's updating when I'm watching. So you might want to exit and rejoin if you can, if you're not seeing the slide changes. I only have one display, so there's no secondary display, so it's just the primary. It says, and I'm verifying on an additional client that it's okay. If all else fails, you can also just watch the recording of it later, but we'll get into that in a bit. Okay, so before we get it too much further, there are some downsides to doing shaping. Alt-Q in particular is very inefficient and has a notable usage penalty. You might see about 10% loss. Could be more, could be less. It depends on your environment, your traffic, your hardware, your NICs. There's a lot of variables there. If you have a very fast system and you're not running anywhere near your wire speed, you may not even notice the loss. The only time you might really notice it is if you're really trying to push the limits of your circuit, your hardware, or your link, whatever. Also, Alt-Q is not set up for all NICs or all types of NICs. Like in particular, VLANs are okay, and VLANs on top of lag are okay, but you can't use Alt-Q on straight lag interfaces. The support varies by NIC driver, so you need to. We have a list in the book, and also if you look at the FreeBSD man page for Alt-Q, there's a list of network cards in there that are supported as well. Although it's not 100% accurate because we know there are some drivers out there that have had issues, and we don't allow them in our GUI because they've had issues. You know, things like the Chelsea driver we've reported upstream, and there are cases too where a NIC may work okay with Alt-Q and our code hasn't detected it. We've tried to straighten out as many of those as we could in 2.3, but in some cases, you know, if we don't have the hardware to test, we can't 100% confirm that. But we were able to clean that up a bit. So in addition to Alt-Q's shortcomings, shaping will add a little bit of latency because there is the queuing action involved. Usually it's pretty minor, it's fairly unnoticeable, but again, it all depends on your configuration, your system, everything as to how bad that is. But it's in most cases people barely notice it, so the benefits usually outweigh the drawbacks there. Another part that's good to be aware of is it's tricky to shape inside VPNs. PRIQ doesn't handle this too badly. Your main concern with PRIQ is not going to be VPNs, but if you're using something like HFSC that's more concerned with bandwidth, you can have trouble with those because your VPN, say, rides on your WAN. Like with OpenVPN, if you have your VPN interface assigned and you want to prioritize something inside the VPN and then other things outside of the VPN, it's going to think you have twice as much bandwidth as you really do, and it's going to run afoul of the shaping algorithms. It's not going to kick in some things because it thinks you've got bandwidth to spare when you don't. So just some things to be aware of there. There are some ways around various aspects of that depending on what you're trying to shape. But that's something that, I mean, if you're trying to do that, you can try it with PRIQ, see if you can get it to work. If not, you can just, you know, if you have support, you know, get in touch with us. It can be kind of tricky. You may need just a little bit of guidance to get that done. All right, so why are we using PRIQ? I've mentioned it a few times as we're going along here. It's the easiest Alt-Q shaper type to work with. It's still very flexible. You can use it for just about any use case. It's great for putting VoIP in games above other traffic, which is most people want to do. They don't really care about about bandwidth allocation so much as making sure that their important traffic gets delivered first. PRIQ doesn't have any concern for bandwidth, so it can also work around some issues that NICs have, like we know Realtek NICs, and also in cases like lag with LACP and things like that. Those types of interfaces don't always report their bandwidth properly in a way that PF can read, and so you can get rule failures in the shaper with HFSC because it can't calculate your bandwidth properly because it can't tell the link speed. So you may hit a situation where a config appears valid, but it's failing. It says you don't have enough bandwidth, whatever, and it's really the fault of the driver or the configuration that we can't really detect in all cases. So using PRIQ in those instances will work around other bugs and problems. And like I mentioned, PRIQ is priority only, so you don't have to worry about bandwidth limits or caps. You don't have to worry about reservations to calculating or designing any type of queuing. With HFSC, you have certain things you have to be aware of. You can't have things that are over 30% here, and they can't add up to more than this percent or this amount of bandwidth. And there's just a lot of things you need to be aware of when trying to design your queues for HFSC. With PRIQ, you don't have to care. So it's a lot easier to work with that way too. All right, so figured we'd just go take a brief run through the Shaper Wizard. If you haven't been through it yet, it's very straightforward. It's just here under the firewall menu, then Traffic Shaper. I already have shaping set up on here. The wizard retains your values from a previous run, so you'll just see what I put in there the last time, and I'll explain it as I go. The wizard is by far the easiest way to get through all of the shaper setup. Even if you're not going to use the rules and the queues that the wizard sets up, it's great to use it just to get a good starting point. So when you get into here and you have all of these, you can use these directly like most people do, or if you want to customize it, you can take these as an example and create your own that are made the same way or have slightly different values, or even just adjust these, add your own in between, whatever. It just gives you a good footing that's a known good place to start. Now the wizard you're going to want to use is this multiple LAN/WAN wizard, the one on top. That's for most all scenarios where you have either one or more WANs and one or more LANs. The dedicated Lynx Wizard, it comes about when you have multiple LANs and multiple WANs and they don't have any interaction between each other. So a case where you have a LAN 1 that only goes to WAN 1 and a LAN 2 that only goes to a LAN 2, kind of a rare scenario, which is why we're not really going to worry about it, but it's there if you want to go that route. So we're just going to do multiple LAN/WAN. Off we go. On the first screen here, it asks you what your interface count is, like how many you have of what type. Your WAN connections are only going to be validated against the list of interfaces it has on the system that have a gateway configured on the interface. Now that could be a static configured gateway. Actually, like on interfaces in WAN, you have a gateway selected there, whether that's directly there or if it's a dynamic gateway like PPPoE or DHCP or even like OpenVPN, whatever, those can be considered WANs because they have a gateway. So if you try to put in that you have 3 WANs and you only have 2, or you have 2 WANs and a third doesn't have a gateway set, it will toss that back as an interface, as a input validation. Some people run into that because like they're running BGP and it handles the default, and so it gets flagged as a problem here. We're trying to work around that in the 2.3 wizard. I'm not sure if we have yet. But if you look there, you can, in a case like that with BGP, you could temporarily put a gateway on to get past this check if you have to. But basically, most people won't have, just put in however many WANs you have. They're probably already configured right. But if you get an error there, that's how you want to work around it. Your LAN interfaces, they're the ones that don't have gateways set. So in this case, I've got 2 WANs, I've got a LAN, or I've got 1 WAN, I've got 2 LANs, I've got a LAN, and I've got a DMZ. So I just do 1 on the top, 2 in the bottom, off to the next one. So on this one here, we just need to follow along and make sure you read these because this is like LAN number 1. I made sure it's my LAN, selected the PRIQ scheduler. LAN number 2 is my DMZ with the PRIQ scheduler. WAN number 1 is my WAN with a PRIQ scheduler. The wizard makes you enter a bandwidth here. PRIQ really doesn't use that, but it does still want you to enter that, so you may as well put it in and make sure it's somewhat accurate. I've got a gig link here. I just put in 900 meg just because I just chose that arbitrarily, but I could have put in a gig there if I wanted. Off to the next screen. Next screen, whenever it decides to show up, is for VoIP. And, well, just waiting on my VM to come back to life here. Hello. Where did it go? Let's see what happened to that guy. now, I don't know if I lost my connection to my server here or what. Give me a second. Double check, make sure if I can get there. Nope, there it goes. Alrighty. All right, next screen is for VoIP. Just if you want to prioritize VoIP traffic, you just check the enable box here. The provider choice customizes how it matches your traffic. I've just got it on generic low delay, which is actually going to match any UDP traffic going to or from the IP address here for the upstream SIP server. You want to match on the remote server, primarily because you can't match on a local address if you have NAT involved. And so, like if you have a private IP address on your PBX, it's going to be a problem. So you could match some of the traffic, but not all of it, because NAT happens on the way out on WAN, and by the time it tries to match that source, the source is changed. So in cases like this, when you can't really match the port specifically, matching on the upstream SIP server is better. And this could be an alias that contains a bunch of IP addresses. Like say some VoIP providers will give you multiple SIP servers, or you may have multiple SIP trunks, or they may have separate SIP servers and audio servers that you don't want in a collection, so that you may have an alias that contains all of those, and then you use the alias here. You could use one of the other choices here if you actually have one that's like Voice Pulse */Vonage or a Panasonic TDA. Those just change, like I said, the ports and the way that it matches the traffic. Since we're using PRIQ, in this case, the VoIP section is smart enough, you can leave these connections blank if you want. Because we're using PRIQ, it doesn't concern itself with those. All right. The next screen is the penalty box, which it's not really used with PRIQ. How you might go about using that would be if you have a known bad host, if you want to limit its usage, you can set that up. I'm still not sure why on earth my VM is acting up here. Because it's showing me it is sitting there idle, and yet it does not want to go through. Let me back this off here. Run back quickly through the shaper. Just gave it a little kick. All right, there's a penalty box, which we're not going to use. Scroll right on by that, go into the peer-to-peer. So the peer-to-peer screen here attempts to match based on protocols you have listed here. The problem with matching these is it's not very accurate. A lot of, especially in the case of BitTorrent, it can use different ports and different protocols and hop around a bit. It's very difficult to detect, but this will at least let you get the default ports, which may get a few of the people who really don't know any better. But it's better than nothing, but it's one way you can try to identify them. The catch-all here option, I would not recommend using that. Some people swear by it, but it's a management nightmare. It sounds good on the surface, but it's not something you want to get into. What it does is it changes your default queue to be the lowest possible priority. So anything you don't identify with rules and put into a higher queue is treated as peer-to-peer traffic. Now, what you can identify as valid traffic, anything you want to match with firewall rules, but sometimes it's just whack-a-mole trying to go through and figure out everything. Oh, well, why isn't that traffic flowing? Oh, well, because it's not classified properly, and you have to make sure it gets into the right queue. It's falling into your peer-to-peer queue. You have to make another rule, and then you think you're going okay until somebody else's app fires up that you didn't account for, and then they've got some other traffic on yet a different port that needs it. And then all of that is for naught the moment somebody sets their torrent client to use a port that's got a high priority. So it's kind of crazy, but just something to be aware of. So I don't recommend using that. It's especially not very useful with PRIQ, but if you want to use that, you can. Just do so knowing that it's going to be a lot of work to make that viable. All right, next up is games. This one's pretty straightforward. We have a lot of popular game consoles and specific games on here. um, Pretty much again, it's a good starting point. If there's something on here that you want to use, just check it. If your game that you want to use is not on here, just set something similar, and then you can clone its rules and adjust or edit the rules and adjust the ports, whatever you need to do. Again, it gives you do you want to at least enable this and check something so you get the queue in your list, and so you get a good rule you can work off of. A lot of these will work out of the box, but for the ones that aren't listed, you should be able to get them to work without too much effort. You may just have to Google around a bit, check in a forum for the game, and find a list of ports for it. All right, next up is raising and lowering other applications. This is where the meat and potatoes of most of your other common protocols, especially if you've decided to use the catch-all, you're really going to want to assign anything here that you would all see on your network to a higher priority queue or lower priority queue, because even the lower priority queue in the catch-all case is still a higher priority than the peer-to-peer case. So something else you might want to keep in mind. These are broken up by general idea of what the protocols are. Like there's remote terminals, services type things. There's messengers, VPN, mail, multimedia, miscellaneous, whatever. So in all of these are very subjective, and it depends on your network. In some cases in a work network, some of these things would want to be very high priority and some would want to be low. In a home network, you'd have the exact opposite. So we can't really tell you what to set here because it's entirely up to the needs of your network. But things like you might want HTTP traffic to always have a higher priority. With streaming, again, on a home network, that might be a high priority because you may want your audio to always be clear. On a work network, they may not give 2 bits about audio, and they may want to make sure other important traffic is better, so that would be a lower priority. VPNs you generally hire. Just pretty much as long as you on this screen, it's a good idea to set at least one thing high and one thing low. That way you get the queues and you get some rules to use as a starting point. Even if you don't use the specific protocols, it's good to have at least one thing set. And that's really it for the wizard. Just finish that up and it will go through and it will reload your rules. And see, mine says done, the rules have been reloaded. That means it reloaded okay and the shaper was fine. Should you encounter an error here, it will tell you what didn't load right. And if you try to use HFSC, you might have a problem with your NIC, like I mentioned. Sometimes you can work around that by editing your queues and working out the bandwidth and whatnot. But with PRIQ, it would be extremely rare to have an error here. And if it is, it might be, I'm not even sure what would cause that to fail on PRIQ. But if it is, just find what the text is, and we have some of the error cases documented in various places, either the Redmine or forum or whatever. All right, and as I mentioned before, the wizard does retain all of those values you put in. So if you need to run back through it again and change something, you can just go right back through the wizard, step all the way through it, and at the end it will put out, it will just refresh your settings, make the changes you had. So don't be afraid of rerunning the wizard. All right, so let's take a little look at our queue structure here. Let's go under Firewall Traffic Shaper. I'm looking here at the by interface view. You can also look on the by queue view that flips it around and goes the other way. In this case, you'll see each interface is here, and on that particular interface, it shows your scheduler and the bandwidth and whatnot. Each interface has a similar set of queues with a couple of slight differences, like on your LANs. Your LANs have a link queue that tries to make sure that your LAN to LAN or local traffic doesn't get shaped. That's also typically your default queue on your LANs. And then your WAN interface has a default queue. So going down the list here, from highest to lowest, your VoIP traffic that gets identified is going to be the highest priority, delivered first. TCP ACKs are going to be right under that, and games under there. Your your raise lower other protocol selections that were chosen as high are there. And then under that is your default queue on the WAN. That's where your unclassified traffic goes in your without your catch-all set. If you have the catch-all set, then it goes to the peer-to-peer queue. Queue others low is the raise or lower other applications, the ones that were chosen as low priority. And that is a priority of 3 on your LANs and 2 on your WANs. Your queue link, which I mentioned is your LAN to LAN traffic, is a priority 2. And then the peer-to-peer queue, which is the lowest, and it would be delivered last. So you can keep those priorities in mind if you're going to make adjustments. And remember, with PRIQ, you can have from 0 to 15. The Wizard only uses 7 because it only has about 7 different types, but you can go higher with PRIQ if you want to. All right, so let's go over how to do the floating rules, which is under Firewall and Rules over here on the Floating tab. And all the rules from the Wizard are in this list. And like I mentioned, they're a good example as a starting point if you need to make adjustments. These rules all use the match action, which I'll show you here. The action up here is match. That's only available here, and it does not pass or block or reject. It does not make a traffic decision. It only has a queue action. So all it does is queue traffic, identifies traffic and places it in a queue. It doesn't matter if a pass rule has passed it or whatever else happened, the match rule can still match it. So you can match based on any criteria that can be used in a firewall rule. So whether you want to do a source address, destination, whatever, the only real caveats are keeping in mind how PF processes packets. Obviously, like I mentioned before, with outbound rules on your WANs, NAT is going to apply before these rules take effect. So you have better luck matching on a destination or a port. Not so much if you try and do a source, unless you have public addresses on your local network and no NAT. Where you actually choose your queues is down here under @queue/queue. The main queue is what you're going to use on like UDP traffic or other protocols, but in some cases even TCP. Generally with TCP traffic, you'll have both an @queue and a queue. See, like this game one here is a TCP. It's got an ACK queue and an ACK. I kind of touched on that a little bit before about ACKs. For every packet you get sent in TCP, you have to send back an acknowledgement saying, hey, I received that. And so for things like, especially with gaming, which mostly uses UDP, but if you have some that's TCP, or with downloads, things like that come through TCP, your ACKs have to be delivered very quickly in order for your data packets to come through in a fast and efficient manner. If your ACKs get held up, then your download or the data coming through is going to get held up as well, because the other side is going to wait for that ACK. It's only so many of those can queue up, remotely before it will continue to send data. So you want to make sure your ACKs flow pretty quickly. And so those get high priority if you have TCP set. So, all right, and the ACKs generally don't have a payload; they're just an acknowledgement packet, so those are usually safe to fire off pretty quick. In the floating rules, they work a little bit differently than your rules on your other tabs. The other tabs are always a first match wins. The rules on the floating tab are generally last match wins unless you check the quick option, but that option doesn't work with match rules. So match rules for queuing are always last match wins. So you need to be very aware of that. In a case like this up here, with your VoIP at the top, you will find in some cases that you might have your SIP traffic falling into like a game queue. And that might happen if your RTP range falls within, a port range that's used for a game, just like this one, for example. If your RTP range was 20,000 to 30,000 instead of the usual 10 to 20, it would hit this rule and match and say, oh, I'll be in queue VoIP, but then actually it would come down here and hit this rule and would fall into your queue games. So if you see your traffic hitting the wrong queues, most likely it's because there's another rule down here that it's matching. So you can try and rearrange the order of things to have it match in the way you want. Just for an example, if that were to have happened, you might want to move this rule, like this rule up above your VoIP rules, for example. And when you do that, it would only fall into the game queue if it was not going to your PBX, for example. Or you could try moving these all the way to the bottom if you want, just as an example. All right, we already talked about outbound NAT. So talk about testing and troubleshooting, how you normally do this. Once you have your set of rules and queues and everything made, when you apply the traffic shaper settings, that is only going to apply to new connections made from then on. It does not take over things that are already running. So what happens is you might see traffic falling in your default queues that you don't know. Like, why is everything in my default queue? Well, it might be a session that was running when you started, or before you started the shaper. So the session was already there, you put on shaping, and it's still going. So in order to properly test shaping, between any change you make, you really should reset your state table. So that would be under diagnostics and states on the reset state tab. And you can reset your states there. So I'm not going to do that now because I've already had the shaper on, so it's going to be okay. But if you do notice things going in the wrong queues, that's one of the first things to check, is make sure the states were not active. So we come over here, we look at our queues. I have going over here, or about what I'll start is a little SIP traffic tester called SIPP. I've got a server here. Let me fire up the server. It's going to accept some connections, and I have a client here that's on the LAN behind that firewall, and I'm going to start it up using a client profile, going to the PBX, and you can see here it's doing about 10 calls a second, and we can see the traffic flowing into the VoIP queue here. Our queue others high is because I put HTTPS in a higher priority queue and I'm looking at the firewall through HTTPS, my browser traffic is going into queue others high, so that's why there's some traffic there. The VoIP traffic, you can see it slowly ticking up. It's going up and up and up, so that as the calls are identified. And if you were to fire that up and you saw your traffic hit some other queue, like I mentioned, check your states, check your rules. It's either the traffic, if the traffic's in the wrong queue, it's either because it had an existing state, or it hit a rule you didn't expect. Whether that's because of the rule ordering, or maybe it just didn't match. It's hard to tell. But double check your rules. Make sure you've got all your rules set right. Occasionally, you might see some drops on here. If you see drops in a lower priority queue, that's okay as long as your higher priority queues are delivering your traffic, because all that really means is that a low priority queue filled up, it couldn't queue anymore, and it had to drop a packet so that it could keep its traffic flowing. And drops are going to happen. That's how things will get slowed down if they can't be 100% queued. It's just a natural part of how it will get the clients to back off and slow themselves down. So it's not really a big deal to see drops unless you see some drops in a high priority queue and like there's nothing else going on, and your high priority queue might be getting a drop. In that case, you may want to edit your queue and change your queue length, increase your queue length a bit. So there's a little bit more space in the queue, and that can happen in some cases if you have a lot of high bandwidth concerns there. So Okay, so yeah, so if you see a lot of drops, if it's a low priority queue, don't worry. If it's a high priority queue, you might adjust the queue length, but in some cases, even then, it's not a lot to be worried about. So a lot of people see drops and they think, oh no, I've got drops, what's wrong? Well, there may be nothing wrong. So it's just something to be aware of. All right, so that's really all there was to it for shaping with PRIQ. Let me go ahead and kill that thing. If you have any questions, go ahead and start typing them out. I know typing can take a while, so you might just type a letter or a short word or something. Let me know you've got a question coming. Let's see. What's the easiest way within pfSense to determine what criteria used to classify traffic? For example, use Citric receiver, but it's not listed in the list of predefined remote desktop protocols. That you're going to have to match it with PF rules. So you'll have to figure out a way to match it in the rules. Whether that means you have to look up and find a list of their servers or a list of the ports they use, or some way you're going to have to identify that traffic. But I mean, if it's a pretty complicated protocol, it may require matching, a list of networks or a list of ports or both, or somehow you have to figure out how to identify that traffic. That's really up to the protocol itself. You might have usually when protocols are around like that, you can usually find some form of identification on either a forum of theirs, or in some cases the really nice ones will have a list of such things in their documentation. They'll say like, for traffic shaping purposes, use this network, or these ports, some sort of guidance. But there are some protocols that are extremely difficult to identify, and you may have some trouble trying to classify them. But uh, just have to take those as you can. You just have to do them as much as you can. In some cases, you may, if you have a local client where it's just one client that needs to go there, you could even just prioritize all traffic to and from that local machine if you can. But as I mentioned, that matching on a local machine address is a little bit tricky, but there are other tricks you can use as well. Like you can actually, in pass rules on the LAN, you could tag a packet and then match outbound on WAN for things that match that tag. So you might be able to work around something like that way, but it really depends on the protocol. And there are some protocols for things like TeamViewer that you may never actually accurately be able to classify and shape, just to the nature of the protocols. All right, anybody else? Oh, something else I thought of too. If you're looking to identify something, it's not a perfect measure, but you could, fire up the client on a local machine and then filter your states. Like go into your states table and filter based on your client IP address and see what it's connecting to. Look at your, the remote IP addresses and ports and things it's using. Kind of note those down. You might even have to make and break a few connections, see if you can identify it. Again, not perfect, especially if it hops around between servers and ports, but that can help. Just look at what's there when the client's running versus when it's not, and you might be able to track something down. Any other questions at all? I said you might type a word or something in the chat. Let me know you're typing something out if you have a long question. Otherwise, I don't want to cut anybody off if we don't have to. But if nobody else has any questions, then we can just carry on. VoIP traffic for Skype, that is a tricky one. That's another one. I'm not sure you can ever really properly match that because it tends to reuse ports and things that are used by other protocols. And we don't have a way to classify things by matching the protocol, especially if it's encrypted. Layer 7 shaper's original purpose was meant for that, but it was horrible. We ripped it out in 2.3. It sucked down CPU and it rarely did what it was supposed to. So we got rid of that. But especially for an encrypted protocol, if it runs on like encrypted on port 443, you may never be able to distinguish it from regular HTTPS. But if you can identify a list of Skype servers, more power to you. But that's something you'd have to look in the Skype documentation, see if they have any way to classify that. But that's more of a question for Skype than for us. Queue length, I went over that a little bit. The queue length, it defaults to a queue length of 50, which just means there's space for 50 slots in the queue, for 50 packets, more or less. And it's going to, if you've got like a steady stream of VoIP traffic and your circuit's full, lower priority queues are going to fill up and then eventually have drops as the queue's full. So if you notice the queues if you see a lot of drops, you may just need to increase the size of the queues if you're noticing a detrimental effect on your traffic, desirable traffic especially. So really, it's just something you can keep an eye on and watch out for drops and things in your other queues. But there's really not a whole lot to it. I mean, it's just the defaults are good for a lot of things, but in cases when you have a lot of bandwidth and it ends up doing a lot of shaping or queuing, then you might need to increase your queue lengths especially. Let's see, would you ever go over the settings change you go over with your pfSense installs? I don't imagine you use it out of the box, but I'm guessing there's settings you change for pretty much every install. Actually, no, because most of our defaults are good. There's really nothing we change for every installation, except for maybe turning on SSH and setting a couple of things that are in the setup wizard. Every setup is going to be different in some regard. So there's almost nothing you'd really want to tweak on every install, because if there's something we wanted to tweak on every install, we just make that the new default. So that's kind of a rare thing. I know we've had a couple of requests for similar things like that, just like do a whole basic setup hangout, and really it'd be kind of boring because most people's basic setup is just going to be install it and run it. We try to make our defaults pretty sane. Oh, for tuning and troubleshooting, yeah, again, that all depends on your NICs. Everybody's NICs are going to be different. You're rarely going to have more than a couple of them that are the same. And like on hardware we sell, we do tweak those, but we tweak them sort of just how it's listed there, maybe a couple of other little things, but in most cases the defaults are what we want, so we just we just go with the defaults. And if we don't want if we want to change it, we just change the defaults. No, we did not discuss using DSCP values. We just a quick for the diffserv code points and matching TOS bits and things. You can use those to match on rules. Like if you want to identify your VoIP traffic, and you know that, you can use that as a criteria on the floating rules used to match. Let me quickly go into the rules and show you where that is. You cannot set the bits. You can only match them, just so you know. So you have to have your PBX, your handsets, whatever, they have to set the bits. But if you know you're always going to have them here, you can match the different DSCP values here if you want to. That's just another way you can use to identify VoIP traffic. But again, that would have to be in every packet coming from that made the connection. If your DSCP values vary from one packet to the next along the same connection, that's not going to help you with shaping unless you do funny things like disable state tracking so it does every packet differently, which is kind of crazy. But no, pfSense itself cannot set DSCP values. But if your clients do, then yes, you can use it to match it as long as it's set on the initial packet that makes the connection. Then you can match that and have it actually apply a shaping queue. But again, that's kind of tricky. Like I said, if it changes from packet to packet, you have to jump through some hoops to make that work. Those are really not intended to be used for stateful tracking firewalls and things. They're meant for more like routers that judge packet by packet. But yeah, if you can set a DSCP value and it sets it in every packet, by all means match it using those rules and your floating rules. Same rules apply with that as anything else. We just use it as an additional criteria in a firewall rule, or just use it as the only one if you want. It operates the same as the other rules. You just last match wins for the match action, and just make sure it's at the top, bottom, or whatever, as long as it's the only thing that's going to match that. All right. Anything else? All right, just a reminder, this session is recorded, and the recording will be put in the Hangout archive that you can get to. So if you missed some or all of the presentation, you can go to just log into your account A member and go into the Hangout archive. It won't be there immediately after because we do have to upload the video and process it a bit, but it should be up there sometime this evening or over the weekend. Let's see, setbacks combining shaping with snort. Well, snort can't interact with the shaper, so your only concern is going to be load-based. And like anything else, alt Q's got a performance penalty, snort's got a performance penalty. If your hardware is up to it, there's no setback. But if your hardware is not up to it, then yeah, you might suffer some throughput penalty because of the extra processing. But snort's not going to help you with shaping. Shaping's not going to help you with snort. So the only concern there is piling on the load. So it's just a question of your hardware. Anything else? Anybody? I'm hoping this is going to be the last Hangout I do on a 2.2 release VM. Most likely from here on, we'll be doing our Hangouts and everything else on 2.3. So yeah, again, for those who might have missed it in the beginning, if you're not testing 2.3 yet, you should be. You can grab it from snapshots.pfSense.org. You can upgrade a 2.2 or earlier system up to 2.3. But you may not want to use it in production yet. We all use it in production. We're using it very happily. In some cases, it's even more stable than 2.2. But there are still some things that might catch some people. So as with all things, test it first on your network. But 2.3 is definitely something you want to be testing because we want to get as much feedback as we can, make sure everything is good, because we made some major changes to the GUI and other places, and we really want to make sure that everybody's happy. So, and that we didn't, we want to minimize the impact of any potential regressions. So, we really want to get everybody testing it if you can. Let's see, is there any way to assign a firewall alias as a higher priority for general traffic? I'm not sure what you mean there. You could make an alias with whatever hosts you want to or ports you want to identify and match it with a rule and drop it in any queue you want. You just have to make sure it gets, that your queues are right. I think you have to, you can't have two queues on the same interface with the same priority. So if you wanted to add your own queue, like somewhere like say between VoIP and games or games and high or whatever, you could, you'd have to adjust the other queue values appropriately. But if you just wanted to identify your own traffic like that with an alias and drop it into the high queue others high, whatever, you can do that. Or if you want to change your default queue for the interface, you can just edit the other queue and check the default on that instead of on your default queue. Generally, you wouldn't want to change your default all that much, but you could just match everything and drop it into whatever queue you want. If you want to do just general traffic in there, then just match it in a rule, set the queue. It's the same answer for anything like that. How do I get this traffic into a queue? Match it with a rule, stick it in a queue. There's not really that much mystery to classifying like that. Anything you can identify in a PF firewall rule you can use to match. You just have to keep in mind the state matching I mentioned and the NAT. As long as it can be identified in the initial packet of a connection, you can match it in a rule, you can stick it in a queue. All right, well, we just about over the hour mark, so I think I'm going to have to cut it off here anyway. So that should just about do it. If anybody else has any questions, you can always hit us up on the forum or on forum or mailing lists, or if you've got support, you can drop us a line in support. You can always other ways to reach us: Twitter, Reddit, whatever. If you have any quick questions, we'll be able to answer them there. Twitter's pretty bad for support, but other avenues are good for asking questions. Otherwise, we will see everybody back here next month. We don't have a topic set yet, but we'll let everybody know once we do. And we'll see you next month, hopefully on 2.3. Bye.